Welcome. Welcome one, welcome all. We are taking a look at the Apache Zookeeper source code, which is a distributed lock service. I and you, we all of us together are going to take a bit of a journey into the source code of this distributed lock service. Is this abandoned? No, we have a commit from last month. It is relatively, I guess, old. So a distributed lock service is basically like it's kind of like Paxos or a distributed algorithm as a service. And in addition to kind of like keeping your flavor fresh and making sure you don't make stupid distributed service mistakes, and also making sure you don't have to keep re-implementing the distributed wheel over and over again, it stores data. And I think that just as a byproduct of having to do what it does, the data, some data storage is inherent, but you can also, rely on that storage for some things that are maybe a little bit more surprising than I don't know. It's kind of like like some file system feels, in addition to just doing the distributed locking thing. I believe it's also based on the Chubby lock service. Let's ask the wizards. So Chubby, hello. So Chubby has a paper. So Chubby is the distributed lock service at Google. Hello, Haka Alpha. It's good to see you. How are things? So Zookeeper is modeled after Google's Chubby lock service. We can probably find the Chubby lock service paper. Or papier, as they say in France. And if you were in France, welcome. Bonjour. Ça va? I'm just going to, out of sheer curiosity, make sure we didn't cover this before. I feel like we haven't. No. Okay, great. Okay, so here's the, presumably this says a single author. That's unusual for a Google paper. But Mike Burrows, I guess, he may have conceived and built this single-handedly. I don't know back when this was, but what era. But there's a paper here. Maybe I can pop it in the live stream. Whatchamacallit. I can certainly pop it in the Discord. Here's the Chubby lock service paper. But I can also pop it in the description, I think. I believe I have that power. And that way people can look at it as they view or not view, as the case may be. It is slowly loading up. Here we go. So there's the paper. Now you have it. I think people can mostly search on GitHub, so it's easy to find the repo, but I'll add the repo in there. Okay, so how does it work? Should we read the abstract? They always say to read the abstract. We describe our experiences with Chubby. Okay, so experiences sounds like maybe Mike Burrows did not code this from hand. Provides coarse-grained locking as well as reliable, though low-volume storage for a loosely coupled distributed system. For a distributed system, not multiple. It provides an interface very much like a distributed file system with advisory locks, but the design emphasis is on availability and reliability as opposed to high performance. So this never occurred to me, but I wonder if the original thing was kind of like ad hoc locking on a database or on like an NFS type share that they optimized and iterated on. Many instances of the service have been blah, 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 blah. The paper describes blah, blah, blah. There's a rationale. One might argue that we should have built a library embodying Paxos rather than a library that accesses a centralized lock service, even a highly available one. That's a reasonable thing, but they did this. Hello, my auto typewriter. An auto typewriter? Are you a robot? Or autocorrect? Is that what auto typewriter means? So I'll add this paper to Wallabag. I think Wallabag does an okay job of reading PDFs. I don't know if that'll succeed. And then he's like defending the decision to make it a library as opposed to, decision to make it a service as opposed to a library. And we can kind of skip all that. Here's the system structure. There's a master. And the clients, the chubby clients, or as we will think of them, the Apache Zookeeper clients. Presumably, this was at least the original design of Zookeeper. It must have diverged by now. Surely Chubby must have diverged from this as well now. But there's some master. I don't know why it's dots. I don't know if those dots are machines. But presumably, these are machines with the same view of the world. They share Paxos-y stuff. And then the Chubby clients make calls so that they all have the same view. You still would get, since these, at this level, they're not sharing the same, they're not doing Paxos here. This is probably what they talk about in this kind of defense of the rationale. Since they're not doing Paxos at this level, there are like maybe latency issues. And so you have to figure that, but presumably this is so fast that it doesn't matter almost all the time. Except when it comes to like SQL databases, which is where you get spanner and what's the word? Like atomic clocks, specialized atomic clocks. I feel like my video is lagging. Is my video lagging? If I do this, will everything break? I think we might just have to deal with the lag. I'll see if I can, if there's an audio sync issue, I'll see if I can fix it in post, but almost always I can't. Okay, so here's the system structure. It has too many computers that communicate via an RPC. You've got a server and a client. Yeah, it's mediated, yeah, okay, fine. So you just integrate some client into your microservice. A chubby cell consists of a small set of servers, typically known as replicas, placed so as to reduce the likelihood of correlated failure, for example, in different racks. They use a distributed consensus protocol to elect a master. I think they use Paxos, but don't quote me on that. And I think Zookeeper uses something else. The master must obtain votes from a majority of replicas, plus promise that those replicas will not elect a different master for an interval of a few seconds, known as a master lease. And that's periodically renewed. That's kind of just standard distributed system stuff. They find the master by sending a master location request to the replicas listed in DNS. And the replicas tell the client where the master is. And then once the client is located, all requests go to the master until it ceases to respond. Okay. Write requests are propagated via the consensus protocol to all replicas. Okay, so they take requests, like raw requests, I'm guessing, or some like mildly processed but not completed, and those get replicated and all of that. What I was really looking for is more here. So Chubby exports a file system similar to, but simpler than that of Unix. It consists of a strict tree of files and directories in the usual way, with name components separated by slashes. A typical example of is ls. Like the command? Why? Foo wombat pouch. The ls prefix is common to all Chubby names and stands for lock service. ls is so deeply embedded in my mind as the list something. I don't actually know what it stands for. List directory contents. What is the S? Just the S in list? As the list file, the list command, that this is a little bit surprising to me in a Unixy environment. The second component foo is the name of the Chubby cell. Okay, so this is just like we're reaching a thing that's Chubby. This is the cell of Chubby. And then I guess the cell's job is to have this stuff. wombat and pouch. So the foo is resolved by DNS. The URLs presumably will look different in Apache lock servers because they have to use regular DNS libraries as opposed to Google may have custom stuff. Or maybe the server just converts these URLs into whatever it needs. The remainder of the name, wombat pouch, is interpreted within the named chubby cell. And then each directory contains a list of child files and directories. Okay. And then there's some events. Chubby clients may subscribe to a range of events, such as file content modified, child node added, removed, etc. Master failover, handle becoming invalid, which is like a communications problem, and whether a lock is acquired, which is, I guess, different from a master failover, although we're not going to dig into that. And they talk about the API and caching to reduce read traffic. Chubby clients cache file data and node metadata, including file absence, in a consistent write-through cache held in memory. So basically, memcached, possibly something Redis-like. My guess is memcached sessions and keep alives. And then there's sessions and all of that stuff. This is kind of like working out the details. I was more interested in the API mechanisms for scaling. Should we look at these? We can create an arbitrary number of chubby cells, the master, or chubby cells, not sales. And the master may increase lease time, blah, blah, blah. And then there's partitioning. So the interface was chosen so the space of a cell could be partitioned between servers, and they've not needed it. If enabled, a chubby cell would be composed of n partitions, each of which has a set of replicas and master. Every node D over C in a directory D, or D/C rather, would be stored on the partition P of D over C, which is hash D mod N. Where does C fit in? So I don't know where C is used. C's hash is not used, and it's not used in the mod. Oh, hello. You just gave me money, didn't you? Thank you. Which Linux distribution do I like to use? I don't know. I guess where I am now, I'm using 3 different Linux distributions. Just full disclosure. I'm using Ubuntu, I guess, on the on my workstation. I'm using OpenSUSE on a laptop, and I'm using and this VM here that you're seeing on screen is Linux Mint. And the VM is Linux Mint just to keep things really simple, because things like GNOME, and KDE have a tendency to get messed up when you update them, and I don't want any surprises when I'm live streaming. But I would love to have a Linux distribution that I loved. Right now, I don't. I should probably consider Arch. I haven't, but like I have so many different machines with different hardware concerns that moving to Arch, I'm a little bit nervous, would be like a week of having to dive into hardware specific issues and firmware and stuff. And that's one of the things that Ubuntu and Mint, for example, do really nicely. Yeah, I like Mint. Okay, so that's Chubby. That's what, 15 minutes of Chubby. Some of that was just ordinary tomfoolery. Okay, so that's what we were based on. I have spilled tea on myself. And, oh lordy. Okay, back to, all right, so that's what it was based on. I don't know if we can find an up-to-date image of what Apache Zookeeper looks like. Here's benefits, audience. We have producers and brokers and consumers. Are we using that terminology? How does Apache Zookeeper in 2026 differ from the chubby lock service paper? Can you tell how to install Arch and make it a separate video? Oof, that's an interesting question. I guess I could try. Yeah, maybe. I don't know when that will be. We would probably do it on we would do it on a VM just to limit the the blast radius of everything being messed up. Out of curiosity, Haka Alpha, is the audio unsynchronized from the video in your experience? Because it is on my preview, but I don't know how up to date, I don't know if that's a preview problem or a reality problem. Okay, so I got distracted by thinking about installing Arch. This was meant to be for the Google AI. It has evolved into a coordination kernel with distinct architecture and operational differences from the original 2006 paper. So wait-free versus blocking. Chubby provides a locking API where clients explicitly require and release locks. Zookeeper is wait-free. It does not expose locks directly. I thought that was how Chubby worked. It does not. It provides a hierarchical namespace of znodes that developers use to implement their own coordination primitives like locks or leader election. Really? So consistency model, Chubby guarantees strong consistency through Paxos based protocol. Zookeeper uses the ZAB protocol. Zookeeper Atomic Broadcast, which prioritizes high throughput and provides sequential consistency for writes and eventual consistency for reads. Why? Zookeeper Atomic Broadcast. So we'll maybe get into why in a second. So read scalability in the Chubby paper. All reads and writes are directed to a single master. And reads are served by any server. So it's, eventually consistent. So caching strategy. Chubby uses a heavy client. Okay. So as of February 2026, which is now, right? Are we in March? We're in February still. Includes a modern cloud-native features, such as dynamic and reconfiguration TTL nodes. What's a TTL node? Time to live, I assume? Why does it need to be its own node? Ecosystem shift. While still widely used by Meta, Yahoo, and Reddit, Zookeeper is increasingly being replaced by major ecosystems. For example, Apache Kafka has officially removed its Zookeeper dependency. Dependency instead of Craft. Okay, I think we saw. So we looked at Apache Kafka. I think we saw the Craft protocol. I think we tried to draw a picture of it, or like an artistic picture involving Craft singles in the author Franz Kafka, if I recall correctly. So go check out that video if you want to see how that turned out. Okay, so this is a little bit weird. So how is Zookeeper different from using like a SQL database for consistency? So one way it's different is it's more horizontally scalable. While both provide consistency, Apache Zookeeper is a coordination kernel designed for distributed state synchronization. Yeah, it uses watches, one-time triggers that notify clients immediately when data changes. Yeah, so it seems like it's a completely different thing, if this Google AI thing is correct. And then the other question I had is, what was it? Not SQL databases, but etcd. How does it compare to etcd, which is the kind of distributed systems primitive inside of Kubernetes? Zookeeper uses a custom Jute RPC protocol. So etcd provides linearizable reads by default, ensuring you always read the most up-to-date. Zookeeper reads are eventually consistent. That's weird. Why did they go in this? Why did they go in this direction? I kind of want to dig deeper on this. Try plus free. No. Compare Zookeeper's original chubby based design, its current design, and etcd. So the reason I'm going this far into the lore, I guess you might call it, is because if I don't have the right sense of what it's trying to do, I'm going to be very confused and wrong about the code because it's a complicated enough thing as it is. So ChatGPT is saying, from the big table paper, that's not correct. You have made a mistake, ChatGPT. I know you told me at the bottom that you can, but you have. So Zookeeper, I guess the chubby version, had a master-based protocol, central coordinator, handles writes, serializes updates, expects strong consistency via leaders, the clients do, and they have a file system like namespace. And then the current design, it uses Zab. It's faster and more robust leader selection. And then they have these eventually consistent reads. Stale by default. That's kind of crazy. And they have a transaction log and snapshots is how persistence is done. And how's persistence done here? It doesn't say. This is not a comparable table. ChatGPT. And then what about etcd? Flat key and TTL leases. Flat key. So there's not like a hierarchical. Okay, so I missed this part here, or I scrolled past it rather. So it seems like they optimized Zookeeper for speed, and they gave up consistency. Let's ask if that's correct. Can I use this? Oh no, it's not a microphone in this VM. Hey, stop. What have I done? What is this? Can I not type anymore? This is not a problem I've ever had. So I can type outside the VM, but I somehow have messed up the VM itself. There we go. Okay, so it sounds like they optimized Zookeeper for speed and traded off consistency. That seems like a strange thing to do. Not exactly. Zookeeper did not trade away consistency for speed, write consistency for speed, but they did allow flexibility for reads. Okay. Why this was accepted? Because it's Facebook and they don't care. It's mainly used for configuration, leader election, locks, and membership. In many of these cases, slightly stale reads are acceptable. Writes matter more than reads, etc. Okay. All right, now we have to look up the Zab. We just have to pull up the Zab protocol, like a wiki or something. Sometime VM is braked. Yeah, sometime it is broken. And that's the case here. Okay, Zab. Atomic Broadcast. So here's the article on Atomic Broadcast. Here's the article on the Zookeeper. An atomic broadcast or a total order broadcast is a broadcast. Whoops. Where all correct processes in a system of multiple processes receive the same set of messages at the same time. Sorry, in the same order, rather. Okay, so isn't that just linearizability? Because it either eventually completes correctly at all participants or all participants abort without side effects. Okay. So like transactional linearity a little bit. And then Zab. Do we have an entry for here? No. Okay. So let's finally get to the code. I promised you I was reading code, and that turned out to be an exaggeration so far. Let's pull this into its own thing. So now I don't know where I want to look. Tools, I will ignore. Conf, I think I'll ignore. Bin. Could be all sorts of things in bin. Let's find out what is in bin. These are shell scripts. This directory contains scripts that allow easy class path in particular, so easy access to the Zookeeper server and command line client. Okay, so it's like very bash heavy or .cmd heavy. And these are just doing like simple bookkeeping, it looks like. And that leaves us with these. And I'm sorry to be right back. Okay, I'm back. Sorry, I had to shut off a machine. And I see that I have the go live button, but I must be live, right? Because you're talking to me and YouTube says I'm live. I don't know, OBS. What is your deal? Okay. Currently taking my, sorry. I'm sorry I missed these, but developing your own operating system, that sounds amazing. I'm curious to hear how that's going. That's like, I can't imagine. That sounds like a ton of work. All right. So, Zookeeper Jute. Jute, I think we just saw is maybe the RPC service, RPC system. We have Zookeeper server, Zookeeper recipes, Zookeeper specifications. I wonder how well they do the specifications. Is this are they formalizing it and verifying it? Because that would be cool. Contrib is, I don't know, maybe like plugins or libraries that people have contributed. Compatibility tests. That's a good idea. Assembly. Maybe this is like optimized assembly language. Bin package. Oh, no. Maybe just assembling the distribution artifacts, like a tarball of everything. This is just some XML. Zookeeper C client library and include files. Okay, so so I think the files I have open are, or rather the folders I have open, are probably where we want to be. And what I want to know first is, should we go? So sometimes I go through the stuff that I think doesn't matter first, just to get it out of the way, so it's not like weighing on the back of my mind. Maybe we'll just do that with Jute. What is index.java? Public interface index has a Boolean done and a void inker. Interface that acts as an iterator for deserializing maps. Okay, so this is some iterator interface. And we have a compiler and that is presumably going to generate code. Maybe. Here's rock.jj. Whatever that is. Parser begin. Okay, so this is some, I think it's being used for code generation based on the name. I don't know what .jj is, but this looks like they're defining a language. Probably the RPC like definition language or something. And then we have a bunch of types. And we're in the Apache Jute compiler. We have things like types like Boolean, JRecord, like I guess Jute record, JRecord string, huh? But why? Let's look up JJ parser file. Java CC, the most popular parser generator for use in what? For use with Java applications. What's it called? Java CC versus Antler? What's better, Antler or Java CC? Antler seems to have better tooling support, but Java CC produces concise code that compiles down to less than 50K on average, according to whatever that was, Quora or Reddit. I think we've looked at Antler. You can watch the Antler video. You can share it with your friends. You can rub it on your toast. You can do anything with it, really. Anything video related. Parsing power. So Antler uses adaptive LL star, which I think we looked at a little bit in the Antler video, or one of the videos we looked at LL star. Java CC is restricted to LLK, meaning you must manually resolve ambiguities in simpler grammars. Okay. So it sounds like it's simpler, produces smaller code. I don't know why they maintain their own RPC system. Apache has an RPC system. This may be a matter of historical, an accident of history. It may be that their RPC system has some peculiarities, like they want it to be extra fast or something that they're having trouble getting out of whatever the Apache RPC system is, which is very well known, but I'm forgetting the name. I keep thinking of Era, which is the table, like the column-oriented table format. Thrift, Apache Thrift, is I believe the RPC system. And IDL, and Binary Communications Protocol. But isn't it also the RPC? Okay, so Apache Thrift versus Apache Jute. Let's see what this says. Primarily comparing between modern general purpose RPC framework and a legacy specialized serialization library. So maybe it's just serialization. Extracted from Apache Hadoop. Why don't they switch to Zookeeper? Switch to something like Thrift. I sometimes like to inject emotion into a chat for no reason at all. It's extremely difficult maintaining backward compatibility with critical infrastructure component. Yes. Okay, fair enough. All right, so here's the Apache server source code directory. This is Java, so we have to go 12 layers deep before we find anything. GitHub does a nice job of if everything is empty, it will show you just the, you can just go directly to java-filtered/org/apache/zookeeper/version. Java filtered. I'm assuming the Zookeeper directory is what I want. We have lots of stuff here, so we'll look at in a second. I forgot this was in Java. Here's Zookeeper specifications. I hope these are, yeah, look at this, TLA. So they have a TLA file for Zab. They have whatever a pic is. Pic is pictures. Okay, this is not high-end graphics, but this is serviceable. What are these pictures for? Okay, they tell. So there's some paper. I don't know if this is the chubby. I know this is the chubby paper. I bet there's a Zab paper. High performance, something. Okay. How many papers can I read on stream before there's a revolt? Okay, this is 12 pages. I will read it too. I'll read it. I'll add it to my bag. So high performance broadcast for primary backup systems. For primary backup systems. I'm assuming this means like live systems that have a primary slash backup, which in the old days, like in the 70s and 80s, people used to call it master and slave, but for very good reasons, that terminology is no longer used. I think that's what they mean by primary backup, but the language also makes me think of the first thing that comes to mind is like backups, like storage backups, and having a layered backup strategy where you have like offsite backups and stuff. But I think that what they mean is the master and client relationship, which is how the chubby paper called it. ZAB is a crash recovery atomic broadcast algorithm we designed for the Zookeeper coordination service. Zookeeper implements a primary backup scheme in which a primary process executes clients. Shouldn't execute your clients, you're going to run out of clients. And uses ZAB to propagate the corresponding incremental changes to backup processes. So, I mean, this is not my field, but all of this sounds like stuff that has probably been figured out in a million papers on like distributed databases. So the reason I was asking before about like why not just use a SQL database, like the real question I had in my mind is like, hasn't this already been like covered and standardized? Don't we know what the pitfalls are? Why do we need to reinvent a wheel? Is it like what are the peculiarities of the Apache Zookeeper use case that doesn't make that other stuff useful? So for example, if you need consistent writes and possibly stale reads, then I think you can just use read replica with Postgres, right? And Postgres locking. Let's ask Gemini. No, let's ask ChatGPT, even though it failed me before and hallucinated which paper the Chubby Lock service was in. If I need, what did I just say? Consistent writes and reads are allowed to be possibly stale. Can I use a Postgres cluster? There's a whole like philosophy. It's like a whole, there might be a religion at this point of people who just use Postgres. And I think the reason is, first of all, half the reason is that there used to be a main alternative to Postgres, which is MySQL, that got bought by Oracle and never really, I think, recovered. There's MariaDB, but it seems like that was kind of like taking out. Sometimes like two mobs are fighting each other, like the Irish mob and the Italian mob, let's say in Boston. And you take out one mob and the other mob benefits. And so that's kind of like what I think what happened with Postgres is that you took out MySQL and then Postgres went from having whatever, 50, 60, 40, I don't know what it was, whatever the market share was, to having much more market share in the open source world. Okay, so yes, PostgreSQL cluster can absolutely work in that model. So what do I need? Apache Zookeeper. Short answer, no. So why it exists for leader election. So can I do leader election with Postgres? So is it for leader election of like so the Postgres servers already elect a leader. The Postgres clusters I don't know. I'm giving feedback. Okay, so ChatGPT has decided this is an interesting enough question. You can build a leader election using Postgres. I mean, no, maybe you're right. Maybe you have to. Maybe you specify ahead of time which Postgres, which Postgres thingy is the leader. But I'm pretty sure mine do a leader election, and I haven't done anything to it. I just use whatever Kubernetes told me. Okay, so I don't know which one's better. Let's say the one on the right. So what about with Cloud Native PG? I thought my cluster did leader elections. Maybe they just use PG whatever it's called. PG auto failover or something. Yes, it does. Oh, that is of course backstopped by etcd, but how it does it is different than what a vanilla Postgres does. Okay. Yeah. Okay. So I get the point, but it sounds like maybe having etcd in general is kind of like redundant with Kubernetes in some sense. Sorry, did I say etcd? I meant Apache. At any rate, we have a TLA file, which is the main point that needs to be made. Okay. So, what I don't know what Zookeeper-IT is. Zookeeper Italy, Zookeeper Information Technology, integration test. Server. Okay, so these are integration tests. That's great to see. Server/watch. We have one. Maybe that doesn't matter because they have some like formal methods, which we will get to eventually. And then we have Zookeeper client and Zookeeper server. And then I think we're just going to ignore contrib. In contrib, I see stuff like ZK Fuse, ZK Perl. So Fuse is probably the Fuse file system. Perl is probably the language. Python, I'm almost certain is the language. Zoo Inspector, I don't know what that is. Hieu Browser, these are things that look very peripheral. I'm guessing the languages like Python are for clients. And that brings us to the server and the client. And the client, I'm hoping, is pretty thin. A C client interface to Zookeeper server. Okay. So hopefully we can rule it out. So we have some hash table stuff, an adapter, whatever, maybe Windows port. Maybe finding a port to run on Windows. WinPort. This header file is for port pthreadlib, sockets, and other utility methods on Windows. Okay, mutexes and keys, and all that good stuff. All right, and then we have zookeeper.c, which must be the main entry point. It is 5,719 lines with a lot of if-defs and a big switch statement with some auth completion lists. Okay, so we're not going to look, I think, at the client. I think we're going to get rid of the client. We're going to be with the server. Although in the server folder, there's also a client folder. And there's a CLI folder, which is another kind of client. And then JMX, which might be like a Java XML. Compat is presumably compatibility metrics we are definitely going to ignore. Server is presumably the main implementation. And then we have files in here, like zoodefs. Zookeeper.java is probably important. Zookeeper main is probably important. Zookeeper testable. I think I'm going to ignore it. Watcher might be a file watcher. Watcher might be a file watcher. I think one of the AIs told me that Zookeeper watches my files. But then who watches the watchers? Make sure I'm not missing anything here. I think we're good. But what is this last message? Oh, it's just, okay, great. I'm gonna move this to the side until someone comes back. All right. So I don't know why client has a, host provider 4-letter word main. Are these all the nasty words? Send 4-letter word. Send the 4-letter word. Default timeout. What? Usage 4-letter word main. Zookeeper This might be to give us stuff about swearing. 4-letter words. The Zookeeper commands, the 4-letter words. Okay, so these are just commands that are essentially truncated or abbreviated to 4 letters to keep people from having to type too much. And that's fine. Here's CLI stuff. I think we can ignore CLI stuff. I feel like the magic all happens in the server. JMX, ZKM bean info, managed util, JMX Java. I don't know if this is a Java ecosystem thing. Basic introduction to JMX, Java management extensions. Provides the tools for building distributed web-based modular and dynamic solutions for managing and monitoring services. Okay, I don't know what libraries they provide, but that's basically like a distributed systems library, it looks like, for Java ecosystem. And now we have a decision to make. And that decision is whether to now look at the server, which we've been delaying for about 50 minutes, or to look at the TLA file. Which one matters more? I feel like personally, the TLA file matters more and is more different than the stuff we usually look at. So let's start there just for that reason. We have a protocol spec and a system spec. And they each have one file. I don't know how protocol and system really differ. We do have a doc here. It focuses on the implementation of the Zookeeper Atomic Broadcast Consensus Protocol or ZAB 1.0. And we have a link here, which is to something. It's the website, like the documentation website. This documents the ZAB, an atomic broadcast protocol used by Zookeeper to propagate state changes. ZAB at a high level is a leader-based protocol similar to Paxos. Some of the aspects that distinguish ZAB from Paxos is that ZAB recovers histories rather than single instances of protocols. It has prefix ordering properties to allow primary/backup implementations to have multiple outstanding operations outstanding at a time. And ZAB does special processing at leader change to guarantee unique sequence of numbers for values proposed by the leader. Okay. I'm not really sure how to think about all that stuff, but I will click on this and I'll click on that. I'll click all the things. And we see TLA files here. One for this, whatever, version 3.7.0, which I thought we were in version 1. Or maybe, what? We're on ZAB 1.0. Maybe we're on Apache version 3 something. Nearly 4. 3.9. Yeah, okay. So that must be referring to the Apache version. And I don't think we've ever seen a TLA file before. I don't think I've seen one before. And here we are. This is like double dipping, I think, into, what is his name? Larry Lamport? Leslie Lamport. Sorry about that. Sorry to all the Lamport heads out there. But so Leslie Lamport both invented the Paxos algorithm and was instrumental in TLA Plus. I don't know if he invented TLA Plus. He looks like this. Let's see if we can find the part-time parliament paper. The part-time polymorph. Why can't I say that? The Part-Time Parliament by Leslie Lamport. What is this? 1998. That's way later than I thought it was. Okay. That's like a year after Google's founding. Isn't it? So this should say when it was. What about Paxos? Paxos algorithm. Blah, 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 blah. 1998. The Paxos protocol was first submitted in 1989 and named, okay. So it predates the paper. And then Google was founded in like what, 97? 1998, same year. Is that a coincidence? I ask you. The answer is yes, it is. Okay. All right. So does this paper have pictures of the part-time parliament? And did I already add it to Wallabag? So the olive tax is 3 drachmas per ton, obviously. And lamps must use only olive oil. Everyone knows that. So that's not the main contribution. So here's some mathematical results. So this is a mathematical paper. I've never read it. I don't know what these operations do. This is some number of drachmas. So this is for all B. B prime is a subset of B. I don't know what equals sign with a delta over it. But it may be a logical operator that from a logic convention I don't know of. If B, so I think this means if for all B, if B prime is a member of all of the B's, then B not equal to B prime implies that B bal is not equal to B prime bal. Assuming this is bal, it's not so clear on my screen. Okay, and then TLA plus a formal specification language developed by Leslie Lamport in 1999, a year after Paxos. I don't know if this was developed specifically for Paxos. It's been used to prove the correctness of the Byzantine Paxos. Is that different from regular Paxos? All right, so anyway, that's the background. Here's what a file looks like. A key value store with snapshot isolation. We have constants, which are keys. This wrapping is very confusing, but a key is like the set of all keys. This is presumably defining a variable in the language, and this is a comment here. And then this is, I don't know what double equals does, but no val equals, and then we have a comment. Where does the comment end? I can't tell. But it ends somewhere. Where does it end? Maybe it's just a one-line comment. We'll say choose V, maybe such that, or choose V is defined by V not in val. I'm guessing this says choose V such that it's not in val. And then store is going to be the set of all key value stores is a set. This is like a subset operator, like in Python, is a mapping from key to val, cup no val. I'm guessing cup is the union. So this is the, okay, so a key either maps to a value or it doesn't, I think is what this is. And then this is some type variant is equal to, this is kind of like defining a grammar. It looks a little bit like a grammar file, but there's maybe more logical operators. I'm guessing this is for all store and store, for all transaction that are this is like LaTeX, subset EQ, either a strict subset or equaling the transaction ID. For all snapshot stores in the map, I guess, from transaction IDs to store, for all written in this thing, in that thing. I don't know if this maybe it's not for all. I was expecting maybe it would end in some sort of claim. Wait, what? Highlight and paste. Can I do a search for it? Yes. Okay. So what does this object do? Do we get a definition? TLA plus syntax. Summary of TLA plus on, I guess, maybe Lamport's website. So this lambda or and. But what does a lambda mean? There are infix operators. Okay, so maybe we have to go at the beginning. So module begins, the module so extends incorporates the declarations, etc. So it's like an import. We have constants, and this thing f, maybe like this defining operator defines f to be the operator such that f on these things from E1 to En equals expression with each identifier x sub k replaced by E sub k. Okay. And you can make an assumption, and the notation f called on a bracket x in s, I guess this is like defines to be an expression, defines f to be a function with domain s, such that f in square brackets of x is equal to expression. But why does it have square brackets here? I don't know. Okay, so logic. Yeah, okay. Lambda's conjunction, not for all. Great. Okay, so this is and, or, negation, implication, definitional equality, I assume. All right, and then is there a for all symbol in the ASCII representations? For all is /a. Okay, great. Now we have some orientation. I don't know if we'll be able to understand the logic of any of this stuff. So here's this, whatever, this TLA file. This extends leader election. So I guess leader election is, maybe should we look at that first? Fast leader election. Module fast leader election. Is this different from leader election? No, it is the same. I just didn't read the fast part. So, okay, so we have a bunch of constants, including the set of all server identifiers. Set of all server identifiers. And they can be in different states. This is like an enum, looking, following, leading. And then message types, we just have notification. And then a timeout signal, which is none. And then we have quorums. So quorum double equal. Do I still have the specification up? I must have closed it, right? I'm guessing this double equal is similar to definitional equality. I'm not going to recover it. But I think this is some sort of equality statement defining this thing. So the quorums is going to be all the queues that are servers, such that the cardinality of q squared is greater than the cardinality of server. So these, okay. So these are subsets of servers. So if you have like 3 servers, then if you have one queue is not a quorum because 1 squared is 1 and it's not bigger than 3. And if you have 2 servers, 2 squared is 4 and that's bigger than 3, so 2 is a quorum. So that's what this is saying, except generalized to different ends, all the ends. And then a null point is we're going to choose P such that P is not in server. Why is that a null point? I don't know. Well, yeah. Okay, so it's just like essentially like a variable that's outside of the space of valid server identifiers. And we have the server state here. So these are now no longer constants. These are variables. The state can change. The history can change. The current epoch can change. All of that stuff. What were the constants? So do you have to run this for every n? You probably have to do some induction, I guess, on the number of servers or the cardinality of the server set. I don't know how that works implementation wise. And then we have set used for mapping server to integers. So server vars L. I unfortunately closed the document that said what the syntax is, but this is, I'm guessing, some sort of set that has like a tuple, state, current epoch, last processed, etc. Okay. And then we have processing of receive queue, recursive, remove none. So remove none of a sequence is going to, this looks now like functional programming, like Haskell-y. The case of sequence is if remove none called on the empty set, the empty list, or whatever these brackets are, is going to return the empty list or set or object or whatever these are. I don't know what this means, but maybe this is just like next line. But if the sequence is not the empty listy thing, then we check if the heads of the sequence has type none. If so, then we're going to remove none from the tail of the sequence. I don't know what that means. None is just any, none is anything that's not a server, right? I don't know in what condition that would happen. Otherwise, we're going to say the head of the sequence, whatever this operator is, remove none of the tail of the sequence. So this is removing some none kind of identifier, which is maybe being used as a tag somehow because it's outside the server space. I'm not really sure. Or maybe it's like a message. And then we have the processing of ID table and older comparing. And then we have, let's go down here, vote equal. So vote equal is going to take, so a vote one, a round one, a vote two, and a round two. And these are now, we know that lambda is a conjunction. This is maybe defining like a Boolean function that's going to be, that you get by anding all of these Boolean like expressions, I guess you would call them. I don't know the right terminology, so sorry for logic people. But so, but we're saying vote one, the proposed leader is equal to so the proposed leaders are equal. If the ZXID equal, I don't know what ZX is, but checking if these two, so the proposed IDs are equal, and the proposed epochs are equal, and the rounds are equal. So this is just an equality check. So the two things are equal if all their fields are equal, basically. Init last processed, update proposal. We're going to say the current vote prime is equal to the current vote, except we get, like, I guess, get rid of the proposed leader, etc. And then we have this ZAB timeout. And there's a logical clock here. Did we see where logical clock is defined? Yeah. It's just a thing. And it's going to be, I mean, this is kind of, they talk about the logical clocks in the Paxos paper. Okay, there's too much there to unwind with the syntax and everything, which I knew would be the case. But I feel a little bit more in touch with TLA than before I started. And here's another TLA file. This one is the protocol spec. This is maybe the communication I don't know how it's different, but this is the formal specification for the ZAB consensus protocol in DSN 2011. And we're extending these things, and so we're just able to use integers, finite sets, sequences, naturals, etc. And we have, I'm guessing this might be two, compared to what the file we just looked at, they might be two related files. They seem to be both modeling similar things. Because again, we have the state of the server in looking, following, leading. We have the ZAB state, the accepted epoch. I wonder if one is just older than the other, and one is like an update. But this is what TLA Plus looks like. And then presumably presumably it works a lot like any other logical system where you're using proof by programs, that you state all of these logical conditions in a kind of a functional programming way. And then you have like essentially just a type checker. Is that how it works? Or are there like conditions? We have modification history. This one's modified in 2023. Okay, so that's just a peek at the TLA Plus. Let's look more now at the server. How far are we into this thing? An hour? Usually we don't go much past an hour, but we'll do a quick look at this the server. All right. Which folder is this? Is this just the same one? This is /server. This is /zookeeper. You can get rid of that. Zoo defs. So these are going to be some definitions. Zoo defs. We have a config node, which is zookeeper /config. A zookeeper node subtree. And then we have opcodes for notification, create, delete, exist, get data, get children, and these are just integers. So if you send 14, that means multi. If you send 12, that means get children. That's all fine and good. In like protocol buffers, this would be, since these are opcodes, I'm guessing these are part of the communication protocol as well. So these would be, or in protobus, they would be in a different file so that you and the client could both consume them, and you could just see the API in one place, but it's also okay to be in this file. And then we have params. What is this? Interface audience. What is interface audience? Okay, so interface audience public, I think means it's publicly consumable. I'll be right back once more. All right. Okay, so these are just, so zoo defs is kind of like a protocol file. We're defining these opcodes, and that's really all there is to it. I don't know what these are. Oh, perms? Oh, these are permissions. So read, write, create, delete, admin. It's kind of a wonky permission structure. And then we have IDs. ID, anyone, ID unsafe. This is kind of like anonymous, world anyone. This ID is only usable to set ACLs. It will get substituted with the IDs in the client authenticated with. Okay, so this is some authenticated ID. It's kind of a strange API, but that's fine. And then we have add watch modes, persistent versus persistent recursive. All right. Maybe like that's watching a file versus watching a folder. Here's zookeeper.java. This is presumably one of the main entry points. We have 3,209 lines. We're importing all of the things in alphabetical order. That's good to see. Here's zookeeper.proto. This is the like protocol, and we can see the messages. So add watch request, create to response, create request, create response, create TTL request, etc., etc. Get children, get data response, etc. This is the main class of Zookeeper client library. To use a Zookeeper service, an application must first instantiate an object of Zookeeper class. All iterations will be done by calling the methods of Zookeeper class. Very well. Okay, so this is the client. I don't want the client. I want the server. But we see some enum here. So what is it? Connecting, associating, connected, read-only, closed, auth failed, not connected, etc. Okay, get rid of that. Zookeeper main. Is this the server? The command line client for Zookeeper. We're in Zookeeper server, right? what? Here's watcher. We have an interface. Is it just the interface? So the watcher interface defines the two possible states an event may represent. So we have an event and a keeper state unused. This state is never generated by the server. Disconnected, no sync connected. Sync connected, connected read only. This is just an enum with different states. Get int value from int. Get value, blah, blah, watcher type, children, blah, blah, blah. Okay. Does TLA generate the code? I hope it does. I don't think we looked at that. So that was client stuff. Where's the server? Netty. Netty is the name of a server library. So is, I think, NIO. Observer bean. Response cache, server connection, server config, server metrics. Here. Zookeeper server.java. And then bean. So the server has 2,404 lines, and we're importing all the stuff. Zookeeper server implements session expirer and server stats provider, and we have a log and a rate logger, etc. And here are some static methods. Skip ACLs, etc. And I'm guessing that since I saw stuff with NIO and the other thing, I'm guessing the actual server process itself we're just using a library, which would make sense. Large request threshold, Zookeeper server method. We're going to take a transaction log factory, a tick time, a min session timeout, a max session timeout, and some other stuff. Maybe a client ID, a client listen backlog, a ZK database. So ZK must be Zookeeper. ZXIDs must be Zookeeper something transaction. Every change to Zookeeper state receives a stamp in the form of a ZXID, Zookeeper transaction ID. The X stands for transaction, I guess. And it exposes the total ordering of all changes to Zookeeper. Okay. So that's what ZX is from the TLA file, but this is just a ZK database. And initial config, which is just a string and not a config object, and whether the reconfig is enabled, which is just some Boolean. We'll create server stats object, a new Zookeeper server listener implementation. This might be the thing that allows different server implementations. I'm pretty sure an NIO is a server, or maybe it's like a networking library. Defines buffers, which are containers for data. Java NIO, new input output, defines buffers, which are containers for data. Okay, so it's not a server, it's lower level than a server. NIO server connection, it's maybe like a streaming library, and then Netty. An NIO client server framework, which enables quick and easy development of network applications, such as protocol servers and clients. Okay, so Netty is, so NIO and Netty kind of go together. Seems like, so I'm guessing NIO is like fast buffer things used by Netty. Netty is essentially doing some additional stuff on top of maintaining NIO buffers. So maybe there's not multiple implementations, but there's at least one implementation of the server. And where were we? Here. So we create the response cache with some cache size, and then we get a children response cache for the children, and we set the initial config, and then we set up the metrics collector, and we log created server with tick time, blah 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 blah, and then that's really it. Wait, what? We call this init large request throttling settings. And that's the last thing we do. We get the listener. And then what do we do with it? So the Zookeeper server function creates a Zookeeper instance. Nothing is set up. So that's just a really simple constructor. But what do we do after we get the listener? Do we start the server? I don't know. Maybe it's automatically started by the implementation. Is there a start or run? I don't know. But we have this Kenn shut down, and we just ask if the state is running or the state is error. Then we can shut down. And it's just, whether we're running is just kept by like an enum in a state variable. Shutdown will do what? Shut down components. And if the ZKDB is non-null and it's not fully shut down, there is no need to clear the database if we are going to reuse it. When a new quorum is established, we can still apply the diff on top of the same ZKDB data. Okay? Unless you start a new, completely different server on the same disk, which I guess you're not supposed to. And then we have some stuff about registering JMX and all that stuff. Okay, so that's at least a flavor of what the server looks like. It looks relatively straightforward, doing normal server-y stuff, not really anything Paxos-y. I don't know what it is. I've never understood what beans were about in Java, but I don't know if this will tell us. The Zookeeper server bean takes a Zookeeper server with a variable named ZKS, and we get a start time, and we set the ZKS, and we set the name, standalone server port. And we can get the client port and get the name. Is this like a mix-in or like extension methods? Get data directory size. What? What's up with Java beans? Can someone give me a quick rundown on what Java bean is? It's just a class written in a way that exposes certain member variables as properties by using a notation like get x, set x. So it's just data encapsulation like most classes in other languages. A Java bean is a Java class with accessor method naming convention. This is a sort of thing where AI is better because I've never seen a reasonable explanation of what it is. They are just a standardized way of writing Java class so that the tools and frameworks can work. Okay, so it's just like an adaptation layer. Tool compatibility, yeah, okay. Designed for visual IDEs like beanboxes, where you could drag and drop a component. Great. It's a tool compatibility thing. I can get behind that, and I will. All right, NIO server connection. This is presumably just some stuff built on top of NIO streams. NIO server connection extends server connection. Maybe server connection is just an interface, or maybe it's something else. But we're doing real stuff here. We have a queue. I don't know where the queue went. NIO server connection. We're going to take the Zookeeper server, a socket channel, a selection key, a connection factory. Maybe this is doing like affinity sort of stuff. This sock is sock, this SK is K, this factory is factory. And set TCP node delay true. Set SO linger. Set keep alive. And we're recording the address of the remote of like the person we're talking to, I guess. And we're going to add the auth info and the session timeout. So is this just it's just a connection? Is it a session? Yeah. I think this is basically just adding sessions. Do IO. Handles read write IO on connection. If the socket's not open, try to do IO on a null socket. If something's not readable, or if something is readable, we're going to set RC to read. We're going to read the incoming buffer, set it to RC. If RC is less than 0, we're going to try handle failed read and catch some results. If the incoming buffer has no remaining, then we've, I guess, drained it. Then we'll create this is payload file, and if the incoming buffer is equal to the length of the buffer, which it says start of next request, then I'm guessing, I don't know why this is the start of next request, but it just is by, I guess, how they're built. And then we're going to flip the incoming buffer. I don't know what flip is doing. Maybe there's two buffers and we're like double buffering or something. And then we'll set the payload to read length of K. I'm not sure where we got K from. Maybe K is like the request length. And then we're going to clear the incoming buffer. I guess because we've flipped it. Otherwise, we'll set is payload to true. And if is payload, we'll call read payload. Not the case for a 4-letter word. All right. So we're reading and writing from some buffers, modulo understanding how NIO buffers work. Here's the Netty server connection. It's going to take a channel, a Zookeeper server, and a Netty server connection factory. And presumably it's just going to add more servery stuff. Process, watched event. Okay, so these are maybe now we're getting into handlers. So if we call process on a watched event, we also are going to pass in the znode ACLs. Is a znode a machine? I don't know. Zookeeper Programmer's Guide, znodes. Every node in a Zookeeper tree is referred to as a znode. Or maybe it's a file node. Znodes maintain a stat structure that includes version numbers for data, for data changes, ACL changes. Is that a real sentence? It includes version numbers for data changes, comma, ACL changes. So like I'm assuming stat in the sense of like file stat. Okay, so I think this is like a file node. All right, where were we? So we're passing in a list of ACLs, which are znode ACLs. We're going to call zk server check ACL, this znode ACL, which is going to check multiple. For read permission, I don't know how we know we need only read permission. I guess just because we're watching. And then we're going to call get auth info, which is presumably going to get the auth info from like the channel of the session essentially. And then we're going to call event get path of the watched event. So we're checking the ACL on the path that's mentioned in the event and whatever null is. And then there might be some exception. Not delivering event, blah, blah, blah. Okay. And then we create a reply header with the notification transaction ID. I guess this is just like where in the, what is the ordering of the events? I think is probably what's going on here. And then we're going to get the ZX ID of the event itself. Sorry, what is the... I said ordering of events, but I think that this is like the session level events as opposed to Zookeeper level events, like kind of like TCP numbers or whatever they're called. Okay, and then this is some logging. We'll set the watcher event to event get wrapper. Convert a watched event to a type that can be set over the wire. Okay, so this is like serializing maybe the protobuf if this were protobufs, but something to do with the wire protocol. And then we're going to say call send response with HE and notification. E is the event, and we'll get a response size. I don't know if this is marshalling the response or sending it, but we get a response size, and then we just use that to send the metrics. And then send response is going to take a header, a record, a string tag, a string cache key, etc. And if we're closing the channel or the channel is not open, we're going to return with 0. So we've sent 0 response. And then we're going to call create this byte buffer by serializing essentially the header of the response. This is like serializing maybe in like the TCP or I assume TCP sense of like creating a new message with all the appropriate stuff, including the opcode, etc. So sending. Okay, all that's good. All of that's great. Now the question is, where is Paxos? Quorum. ACK request processor, election. Let's look at election. Commit processor, follower, leader. Should we look at leader? Learner. I don't know what a learner is. Observer, multiple addresses. Some quorum stuff, server beans, vote.java. Let's look at vote.java. Okay, so a vote is, so we have a public class. I don't see us importing anything that looks TLA-ish. We still have to look at if TLA generates any code. So a vote has an ID and a ZX ID. I don't know if ID is ID of like the voter. It also has an election epoch is set to -1. The peer epoch is set to -1. And the state is set to looking. And then I guess you just have, you can, this is with only two, this is just constructor overloading. You can pass in more parameters. And then we have getters, and we have equals implementation, which is, I think, the thing that we saw modeled in TLA. And then we have a hash code because it's Java, and you might want to compare hash codes. So that's a vote. An election is, this is just an interface. It has two methods, look for leader, throws interrupted election and shutdown. Great. And then a leader is huge. It's 1,824 lines. And the proposal is going to extend synced learner tracker. And we have a quorum packet, a request, a proposal, et cetera, et cetera. Pure request proposal. Okay, so this is add forwarding leader. This is presumably where we're starting to implement stuff, but we're also doing a lot of kind of like boring bookkeeping as well. So is quorum synced? We have a quorum verifier. This is, I don't think we've seen the quorum verifier, but it's going to verify the quorum. And we are going to create a new hash set of IDs. And we're going to look at the quorum verifier, get voting members, contains key, get my ID. If it contains my key, then I'm going to add my ID. Okay. Is that right now the only ID? Yeah. And then we're going to synchronized. I think this means like the forwarding followers is some kind of lock or mutex or exclusion device. And then for learn handler, iterating over the forward followers, which is maybe just a list that we keep somewhere because I don't see where it's defined in this method. If the learner handler is synced and the voting members contains the key learner handler get SID, then we're going to add it to the IDs, and then we're going to return QV contains quorum. So I don't know what this is. This is essentially some important sub method. So something about forwarding followers and learner handlers. I'm not familiar with these terms in the like Paxos setting, but we can dig into them. And then contains quorum is maybe just the square computation. Connecting followers contains get my ID, verifier contains quorum. Let's see if we can find contains quorum. Act.size is bigger than half. Quorum maj. And what is half? So bigger than half the size. Majority vote. Oh, this is quorum majority. Okay, so there are, I guess, different kinds of quora. Quorum verifier, quorum hierarchical. So let's see what contains quorum for quorum hierarchical. So if for whatever a hierarchical quorum is, we're going to get a hash map, which is called what? Expansion. We're going to add up the weights to a group. Okay, so you know, the captain gets more weights than the private, and the general gets more weights than the captain. And we have to, what do we have to do? I guess just know how many total weights there are and go by majority vote of total weights. Like everyone, you know, if a weight is $1 and you know, the general gets to spend $4 and each private gets to spend $1, let's say, then and there are 100 total dollars, maybe you're looking to see if there's at least 51 in the bucket or something. Is how it might work. I'm just guessing. We have some set. Where did set come from? Add up weights per group. So the set is passed in. And we have an SID, I guess server ID. So we're going to call server group get SID. That gives us a GID. And if the expansion doesn't contain the GID key, then we're going to put it in. Otherwise, I don't know why we don't do more processing here. If the expansion doesn't contain the key ID, okay, we're going to put this. We're not going to put it in. We're going to look up the weight of that server and put that in the expansion, a map rather from the GID to the weight of the SID. That makes sense. And then the total weight. Okay, so this is just in the first pass, we're just putting the things in the container we need to do the calculation, and then maybe this is the calculation or something like that. The total weight will be no, that's wrong. But at any rate, in this else clause, we're going to get the server weight from the SID, and we're going to add the expansion get of GID. And so I don't really know what expansion is. It looks like everything gets added to the expansion. And so when do we not trigger this clause? So okay. So the server group must be a collection of servers. That's what I was missing, is that a server contains multiple servers. And this is saying the first time we see a server from that group, we need to add a map for that group. Okay. And then this is saying we're going to get the server's weight and also add to it the group expansion. Maybe that's how the hierarchy is implemented. And then we'll put that computes the new expansion weight for the GID. And then here is where we check if all groups have majority. So maybe each group gets majority separately, and then we consolidate somehow. So this looks like it's checking if each group has it's a for loop over the groups to see if they each have a majority within the group. And then here we check the mage group counter and check if it's bigger than the number of groups over 2. So this is majority by group. So I think my mental model was wrong. I was thinking of it as hierarchical in the sense that you might have, some people might have more votes, but I think what it's saying is we have multiple teams, and if team A and B want to wear blue, but team C wants to wear red, then because there are 2 teams that vote for blue, we're going with blue. And I think that's what this is doing. We could look it up, but I'm not going to. Should we look it up? Let's look it up. Zookeeper hierarchical consensus. Is that what they called it? The hierarchical namespace used a hierarchical quorum, that's what I meant, used to manage consensus across large or geographically distributed clusters. The standard Zookeeper consensus requires a simple majority. Zookeeper supports hierarchical quorums, which allow for more granular control. These group segmentations, servers are split into disjoint groups, for example, by data center or rack, and weighted voting. You can assign specific weights to individual servers or groups, so there is weighting. So that wasn't, my earlier mental model was not entirely wrong. And then to reach a quorum, you must obey a majority of votes from a majority of groups. This configuration makes smaller quorums in worldwide deployments and enables smaller quorums in worldwide deployments and ensures that a single location's failure doesn't halt in the entire system. So it's a way of getting, if you have the number of communications, like it grows with the square of the number of people communicating. And this is kind of adds a way of having a layer of indirection so that you can incorporate information from all of the nodes without overwhelming everything. I think that it grows with the square necessarily. This is just a graph theory statement, right? Are there any conditions on this? In project management and network theory, the complexity of communication does not grow linearly with the number of people. Instead, the number of potential communication channels increases exponentially. This relationship is mathematically defined as the channels equals n minus 1 over 2. Yeah. This is what you could choose the first one, you choose the second one, and it doesn't matter which order they communicate, so you divide by 2. That's not exponential though, right? I was under the impression that n times n minus 1, so 1/2 times n squared minus n was sub-exponential. Mathematically speaking, the formula for communication channels is quadratic and not exponential. While the term exponential growth is often used colloquially, what I don't understand is why people say like exponentially bigger when like you're comparing two things, because you have 2 points, so that could be a linear increase. But at any rate, yeah. So it grows quadratically with the square. Okay. So what we don't know yet is like what learners are and what the forward followers are. Here's learner. This class is the superclass of 2 of the 3 main actors in a ZK ensemble, followers and observers. It's the superclass, so both followers and observers are learners. Both followers and observers share a good deal of code which is moved into peer to avoid duplication. What is peer? Is peer now renamed to learner? Let's find class peer. We have a peer struct and we have peer info. I'm guessing learner was may have been at one point peer. Validate session. Write packet now. Find leader. Returns the address of the node we think is the leader. So set lead server to null, get current vote, and we're going to iterate over the values. If the SID is the current ID, ensure we have the leader's correct IP address. Okay, so this is just looking in a map. With a linear search, right? Why don't we have a hash table? Sometimes linear is faster for smaller It kind of depends, partially depends on Java, depends on other things too. Okay, so it looks like this has a few different concerns, such as connecting what are the IP addresses, who is the leader, and that's what a learner is. Why is it called a learner? I don't know. Zookeeper, learner, forwarder, observer. Observers are non-voting members, scaling Zookeeper without hurting write performance. Although Zookeeper performs very well by having clients connect directly to voting members in the ensemble, this architecture makes it hard to scale out to a huge number of clients. The problem is that as we add more voting members, the write performance drops. This is true in general. This is a fact. Let's talk about democracy. So this is a fact about information, and Leslie Lamport named his paper "The Part-Time Parliament" because the connection to Parliament is clear. There's voting and all of that stuff. Peers. In the U.S. where I live, we don't have a House of Lords with peers, but they do in the U.K. And so that terminology may have come from there. Jury of your peers and all that. But this is a fact about like voting. So the more voting members you have, the more they have to communicate and performance drops. So you have non-voting members. You have a layer of indirection through like the kind of group hierarchy or the in a human connection. Once a legislature gets large enough, you couldn't have 100 million people in a parliament. You would have some sort of representation structure, and that's it's no surprise that since that's a fact about how quickly things grow. It's no surprise that shows up in Zookeeper as well. And one way they deal with that is that they have observers. And it's just a non-voting member, I think. We've introduced a new type of Zookeeper node called Observer, which helps address this problem and further improves Zookeeper's scalability. Observers are non-voting members of an ensemble, which only hear the results of votes, not the agreement protocol that leads up to them. Okay, so we're reducing bandwidth usage as well by only transmitting the results to the observers. Other than this simple distinction, observers function exactly the same as followers. And I'm guessing followers follow the voting but don't vote. Clients may connect to them and send read and write requests to them. Observers forward these requests to the leader like followers do, but they then simply wait to hear the result of the vote. Because of this, we can increase the number of observers as much as we like without harming the performance of votes. So the idea is that now 200 clients can connect to an observer. The observer is only sending one request essentially to the voting members to find out what the result of the vote is. And then the observer is like a reporter or wire service that says, new pope elected or whatever it's doing. Okay, so that's an observer. That's fine. What is a follower? No, forwarder. Follower? The follower must have arrived at the leader election. Zookeeper is a holistic protocol. We do not focus on individual proposals, but rather at the stream of proposals as a whole. A follower will act the new leader, blah, blah, blah. So, okay, so a follower is just a voting member who's not the leader. Is that right? So the followers, when a quorum of followers, a leader becomes active only when a quorum of followers, the leader itself counts as a follower as well. You can always vote for yourself, is synced up with the leader. So I wouldn't have called them followers. I would have called them voting members or senators or representatives or voters. Okay, so that's what a learner is. A learner is the common code for an an observer, and a voting member, which they call followers. But I thought I saw something about, I thought we saw a bunch of stuff about forwarders or forwarding something or other. There's learner handlers. Here's leader. Start forwarding. Lets the leader know that a follower is capable of following and is done syncing. So this is maybe I don't know what it's forwarding. Should we find out? Let's read it quickly. So start forwarding looks at the last proposed, like assuming like vote proposal, or maybe proposed transaction. If it's bigger than the last seen transaction, then so there's some to be applied is like I guess transaction or like events or transactions that haven't been applied yet. So or proposals, I guess is what they're called. So for each proposal, if the transaction ID is already last seen, I don't know if last seen means it's already been committed or if it's in some other like temporary state, but basically we just ignore the things that we ignore proposals that have already been seen, whatever seen means. And then we're down here, we haven't ignored it, so it hasn't been seen yet. So we're going to queue the packet on the handler. Since the proposal has been committed, we need to send the commit message also. Does that commit it? I don't know. We'll create a new quorum packet with leader commit. I guess it does because we're the leader, right? With the packet ZXID, etc. And then we're going to call handler queue packet on the new quorum packet. So I guess this is like commit. It doesn't call it commit. Seems like that might be a little bit buggy. I would personally call it something more than queue packet, so that it's so that people who don't know the code as well don't accidentally introduce errors that wouldn't necessarily be easily picked up by like code review by somebody who doesn't super know the code base. That's a detail. And then this is like the commit, and this is sending the commit message, the information that a commit has happened. And then we get down here, only participant needs to get outstanding proposals. We'll call handler get learning type. If it's a participant, then we're going to get the key set from the outstanding proposals. Those are the the Zookeeper transaction IDs. And then we're going to sort them. How? I don't know. Hopefully some sort of stable sort. And then we're going to iterate over the ZX IDs. And if we've already seen them, continue. Otherwise, we're going to call a queue packet on the outstanding proposals. So sending out some information about the proposals to the participants, whoever the participants are. And then there's a bunch of other stuff like get epic to propose. I personally, if I were trying to understand this, I would focus at this point, in terms of reading the code. I think we've seen a lot of what you would be working on if you were contributing to Zookeeper. If you wanted to know the details of the protocol, I think you'd be wiser to spend the time looking at the documentation and looking at the TLA plus code, which if you have more time than we gave to it, looks relatively straightforward, in my opinion. And I wouldn't necessarily try to use the code as it exists now as the indication of what the protocol would be. So that's my post hoc justification for ending the stream here and not digging even more into the protocol, which if you are not, if you're like screaming at your screen saying you wanted to see more of the protocol, I apologize. I do want to find out if TLA plus can TLA plus generate code. Generating code is not in the scope of TLA plus. It cannot natively generate executable code. It is a formal specification language. But Haskell can. All right, so let's find, this is the chubby paper. Let's find those. What are the chances it's in my history? It must be, right? Oh, wait, stop. These buttons aren't doing what I wanted them to. Why does this look like a brick wall? I have no history. All right, so let's go back to Apache Zookeeper. I have that open. This will link me to the GitHub repo. And let's find the TLA file. It doesn't know TLA. Okay, I guess it doesn't like that. What does it know? Can I do file type extension? Search syntax tips. Path start dot. Was it path colon? Star.tla. All right, so just out of curiosity, I'm curious how these two files differ. We have system spec versus protocol spec, and one was committed 2 years ago, and one was committed also 2 years ago at the same time. So how do they differ? The system specification references fast leader election Java, 2B, ZAB, quorum, blah, blah, blah. Does this have the other TLA file in it? No. And then this one, for the ZAB, so maybe this relies on ZAB as a dependency, but it doesn't seem to import it. This is fast leader election, and this is, what's it called? Where's the module name? Module ZAB. So maybe it's like a library. I will ask ChatGPT, I guess. Here's new chat. How do these files differ? Can it read? Can it read? Can it read files? Can it read URLs? There are different kinds of formal specifications. They have different roles. So the ZAB is the protocol specification. It contains the ZAB protocol itself. And then this is system specification is the full system behavior, not just the object protocol, including how Zookeeper components react, how leader election happens in practice. Okay. So one is the ZAB is lower level. The system is more implementation centric. Okay. Why doesn't the system one import the ZAB one? Great question. And this gets into how the Zookeeper team uses TLA. It does not import ZAB because it is not a refinement of that spec. It is a separately written model of the Zookeeper system, not a layered extension of the protocol. But why not? Think, what properties must AnonMek broadcast satisfy? Okay, great. Now let's take this file. And ask, I guess, Gemini Pro, how hard is it to generate code based on this TLA spec? I'm just going to paste the code in. Assessing the challenge. I'm guessing it can probably do this. And I'm guessing if you did it in Haskell, or I don't know if other Can Coke extract code? I'm pretty sure it's been renamed though. I don't know what it's called now. Does it generate ML code? Rock. Through a process called extraction. How hard is it to convert TLA plus to Coke or Haskell and then extract the code? I don't even know if they have the same like power type systems. It is difficult and non-standard because TLA plus is a specification language based on set theory and temporal logic. Is it? What are the temporal logic? First of all, let's bookmark it. Second of all, let's add it to Wallabag. I don't know if it's even communicating to Wallabag. Temporal operators. I mean, that makes sense, but we haven't. So this is like modal logic. So box F means F is always true. Diamond F means F is eventually true. I don't know what weak fairness is. Strong fairness. And F leads to G. Weak and strong fairness. I'm in the process of revising some of my workshops. Weak fairness applies to specific actions, descriptions of how the state can change in the spec, not the whole spec. I don't know what that means. And this is taking too long to get to the point. What's the difference between weak fairness and strong fairness? Weak fairness ensures that the execution cannot remain forever in a state where there are enabled actions leading to other states. Under strong fairness, no action can be enabled infinitely often without being executed. I don't know what that means. They ensure that the processes or actions eventually make progress. Okay, so it's a guarantee that things make progress. If an action is continuously enabled, stays ready, and never turns off, it must eventually be executed. Okay, the stick rule. It only guarantees progress if the system gets stuck in a state where that action is always possible. Constraint. If the action becomes disabled, even for a single moment, the timer for weak fairness resets. Analogy. A patient person waiting in a line that never moves. If the person at the front never leaves, weak fairness says they must eventually be served, but only if they never step out of the line for a second. What? If the person at the front of the line never leaves. I think this is just explaining it badly. I think it means that like if you are at the front of the line, you'll eventually get served. I thought it was initially saying that like if you're like the fourth person in the line and the first person never leaves, you'll eventually get served, which doesn't make any sense. So strong fairness, if an action is infinitely often enabled, if it keeps flickering between ready and not ready, it must eventually be executed. So this is for oscillating systems. That makes sense? Okay. A person turned across a busy street. The walk signal turns on and off repeatedly. Weak fairness wouldn't guarantee that they ever cross. Okay. But strong fairness ensures that they eventually cross because the light is green infinitely often. Okay. And then for modal logic, I think for like deontic logic, the box is like obligatory and diamond is what? Permissible? Oh yeah, okay, so box is obligatory and then so let's try a different search. Modal logic. Box diamond. So modal logic deontic box diamond. These don't have the box. These just have P and O, P, and F. But I think that's what it is. I think it's permitted and obligatory. So square is like stronger, I think, in modal objects. Always true versus eventually true. I'll ask, is there a similar and equivalent or related concept in deontic logic? Tell me that. Probably not. Weak versus strong permission. Weak permission, something is permitted simply because it is not forbidden. Strong permission, there's an explicit license allowing it. That seems reasonable. Okay. Great. Now, I was trying to get some code generated, and I was asking about how hard it is. Abstraction gap. TLA plus describes what a system does at a high level. Uses code theory. So there's TLA Coke. Research exists on embedding TLA logic inside of Coke, which allows for deductive proofs but is geared towards formal method experts rather than general code generation. In formal translations, most industrial engineers write the TLA plus spec to find design bugs, then manually implement the verified logic in Haskell or another language. And what? Effort is high versus very high. Requires reproving everything. Really? I'm a little bit surprised at that. But let's see how Gemini does. Guaranteeing executable code directly from TLA Plus is extremely difficult to impossible using current available automated tools. The spec models the network messages and disk history as abstract variables. You must manually transmit. I don't want to do that. I'll say take a stab at it. So even if you can't machine translate in the sense of deterministically doing it, you can certainly ask an LLM to do it for you. This is a conceptual translation of the core state machine into a Java skeleton. Oh, this is nothing. Atomicity. The TLA syntax implies all these assignments happen instantly. The Java code uses synchronized to mimic this. I've reached my pro model limit. Uncool. Uncool. Let's try the simpler TLA file, the ZAB file, which is a higher level file. It is only 12,051 lines of code. Convert this TLA file into executable brainfuck code. I'll give it, I don't know if it can actually read the URL. It is not possible to convert. It is possible. One message remaining. Oh, whoops. I pasted the URL, so I guess I don't get to do it. Let's try one more time. Even though I have 0 messages remaining. Okay. I'll see if Gemini Flash will let me do it to convert it to brainfuck. Translating a distributed consensus protocol like ZAB into brainfuck is a purely academic exercise in mapping complex state machines to a 1D tape. Since brainfuck lacks network I/O and multi-threading, this code simulates a single server state transitioning from election to discovery. Why this is hard. I/O limitations. Brainfuck cannot handle the messages variable from your spec. You would have to implement a manual input buffer protocol using comma. Okay. Well, that's that. And so that ends our or exploration of Apache Zookeeper. I have learned some stuff. I have learned a little bit more about how TLA Plus works. I have learned that Apache Zookeeper seems to have transitioned to a world where they are prioritizing like fast reading and sacrificing the like the strong guarantees of a traditional lock service. I'm guessing that was not done. I'm guessing that was all done for a reason, probably related to performance at like large companies, or maybe the large companies wanted to get more, build more kind of like NoSQL, eventually consistent style features without having another service, or maybe it just evolved out of adding more and more caching, and that adding less determinism. But that's a little bit of a strange place to be, because that kind of opens up Apache Zookeeper to being replaced by things that either provide eventual consistency more cheaply, or things like etcd and Kubernetes that give you stronger guarantees, and also a lot of additional in the ecosystems. There's a lot of additional features. So that's Apache Zookeeper. That's my take on it. I'm curious to hear your take on it. I'm curious to hear if you've ever toyed with Apache Zookeeper, or if you have managed a gigantic Zookeeper cluster at a big company, or if you once stole a Zookeeper cluster from someone. I want to hear all of those stories and more in the comment section. Thank you for joining. I'll see you folks next week.